This is project 4, video number 3, the one in which we do the documentation and finishing touches. So I've already done some of it as I was working along. So let's go with show emrad info. You have to give a standalone description of what the function does in your own words, and by standalone I mean it's the user should not have to read my project handout to figure out what's going on. So I think you have to say it takes 2 arguments. We're going to give input variables and output variables later on, so I think the wave feature name is a character string. This function strips the character string of leading white space, switches it to all lowercase, and creates a substring consisting of the resultant first 3 characters. And if that substring is WAV, it assumes that the next argument is a wavelength in meters. If that substring is FRE, then it assumes that the next argument is a frequency in hertz. And then based on that, it uses that wave feature value to create the other one. So in other words, if it's a wavelength, it calculates the frequency. If it's a frequency, it calculates the wavelength, and then it displays the description of that type of the electromagnetic radiation that has that wavelength and frequency, and it prints the value of the wavelength, the value of the frequency, and the kind of radiation that it is, in terms of is it radio waves, X-rays, visible light, etc. And in determining that, it uses a Wikipedia microwave table entitled the electromagnetic spectrum to establish the boundaries between the types of radiation. Since that's not universally agreed upon, we have to pick some particular source for it. Alright, so that's what it does. When it's written like that, if you write it as 3 times 10 to the 8, anybody would recognize it, but for further explanation as to what this is the speed of light. It represents clarification stuff, but I think before I do the checklist, I want to make sure Jeffrey Schnick. I think I'll get the other one too. Save that. This one, percent give function standalone. If that's one word, standalone function description. This one, given the wavelength and frequency of kind of electromagnetic some electromagnetic radiation, some light, if you will, if you prefer, it prints out the characteristics that I just talked about. So might have to do some repetition there, but you can use copy and paste to do the repetition, so that shouldn't be a hardship. And then after you give a good thorough standalone function description, say that it is by you, and then percent input variables, percent lambda what it is, what percent go F, say what it is, frequency of the light, and then percent output variables. You are required to say that there are none. And I'm going to try copying this over to the other function. Control C. I'm going to go to Control S, and then this one, Control V. Note that C is neither an input variable nor an output variable. It's a local variable. It's used, but it's not input or output. And this is wave feature name. I think I'm going to try copying that there. Control C, Control V, and then waves feature by Control C, Control V. I think that should do it. You could use a colon instead of an equal sign if you want to, but make sure you say what it is. And so trim to lower and take the first 3 characters of it. That's pretty straightforward, and then we're switching on WF name, so if it's wave, we do this, and if it's frequency, we do this. By using standard physics symbols like F for frequency, lambda for wavelength, we've made this relatively self-documenting, so I don't think I have to give any additional details in there. Don't forget to write your attribution. Tell me a story. Let me know what you needed help with. Let's see if I specifically said it has to be right before that end statement. I think I'd like to put it after the end statement. So that the function end statement. But alright. Let's look at the other one. Got my name, output variables, and I can put one more percentage sign before I get started on that. Then it's just print out a bunch of stuff. Depending on what the wavelength is. So I chose to go strictly by wavelength. Oh, that's funny. I did replace all types with some spaces before it. Range values for name types, so that messed up my attribution there. Alright, let's go through the checklist. I think I better do it twice, once for each of them, at least part of it. So I think I did what it said to do. I almost forgot part of it, so let's make sure. Use that particular table. That is to accept the first argument as recognized. Okay, I did that. Display, let's see, displays the corresponding wavelength, frequency, classification, and displays what table is being used. That's the part I almost forgot about. Alright, I think we got basic project description covered. I wrote it to do what it's supposed to do. I got a complete algebraic solution that was more or less nothing. It doesn't say anything about pictures this time. Glad I remembered to take that out because no pictures are required. The whole algebraic solution was just these two formulas coming from that stuff. It's actually from first semester information. And then, so I got that for each function, an outline of the steps. I remember writing an outline for each. So for the program part, try to write it, and did that. A reasonable attempt. Make sure it works. I think I got that. And then nothing but the relevant information, the relevant wavelength figure. And so it was okay to put those lines in there. It was being, this asterisks and the hyphen character being used as lines, being printed once to the command window. So it only prints it once. And one point for document, you must have your name. Code must be well documented. A comment saying what the function does. Another set of comments providing a list of arguments. The input variables. Return variables. If there are no return variables, you must say so. We got none. I said so. That was for both of them. In the case of a function that includes segments that are not self-explanatory, the only thing I said was, what does C represent? It might have been unnecessary, C being the speed of light, but because of the way it was written with all those digits, I thought I should put it down there. That's, by definition, that's the speed of light. It's not an approximation. The meter is defined with respect to that. That's one of the defined things in SI units. One or more graphs. We got no graphs. Attribution. Can't be the same as mine. I think I've actually got both of them covered there. So I believe I did everything for both of them. So I didn't actually do that. You have to do it. Give a standard function description, saying what the function does, and your name. Alright, make sure I got my name in it, input variables, output variables, function description, attribution, one little bit of clarification. Alright, so I just want to make sure that when I was typing that stuff in, I didn't make it so it stopped working. So let's try. What is it? Show EM. I think I just lost my place here. So let's see. Show EM. That's not needed. Alright, so I typed that in and then hit enter, and what got displayed after that is all this stuff, and there's nothing extra. Wavelength, it had to calculate. No, the wavelength was given 500 times 10 to the minus 9th, which is 5 times 10 to the minus 7th meters. That's good. Had to calculate the frequency from the speed of light. Said it was visible. Type of radiation determined from the electromagnetic spectrum table. I'm going to try say 1 nanometer. Says it's X-rays. 10 nanometers, border between X-ray and ultraviolet. Alright, it seems to be working. So I've done the documentation. And so I did some finishing touches as we were working on it to make stuff stand out and be readable. So documentation and finishing touches done. I'm going to call this a wrap for project 4, video number 3.